Hello. Now we're going to see Helen showing us how to quick test your kernel with GitLab-CI with a pinch of salsa. Please welcome Helen Koike.
Thank you, everybody. Welcome to this talk. So first, who am I? My name is Helen Koike. I am a Brazilian. I am a senior software engineer at Collabora. I am currently working with Kernel-CI, and I am a Debian and Linux kernel enthusiast. I started this group called LK Camp in 2018, which is just a group of people, of volunteers like us, trying to understand the kernel, to study the kernel. That is a picture of our first meeting, and I am mentioning this because so this LK Camp group inspired another group called FLUSP in São Paulo, and I discovered here that FLUSP actually inspired Debian Brasilia, and I was really happy and proud that I'm part of this actually. I do paraglide, I climb, I play handball, so a bit of me. My Debian past here, I was part of EFI team. I helped with adding support for secure boot in Debian, and I also participated in the cloud team some time ago. So what we will cover in this talk, so I wasn't really aware how many of you knew about GitLab-CI. It seems that a big part of you already uses Salsa CI, but so I decided to add a really crash course on GitLab-CI. So we'll talk quickly about Debian, Salsa, and Salsa CI. And then we'll move to why GitLab-CI for Linux kernel development. And then how to use a few pre-made pipelines in GitLab-CI to test the kernel. So we'll cover those three types. Then a bit about the CI for Linux kernel Debian packaging. And future steps. So a crash course on GitLab-CI. With GitLab-CI, you can define what we call a pipeline. So there is a special file that you can write, usually called .gitlab-ci.yaml. And there you can define jobs on GitLab-CI. And once you push your code, runners will pick these jobs, execute them, and generate results that you can see on GitLab-CI. So this is an example. Let's go through the source code first. So this is a definition of a YAML file. So for instance, you can define a job called build job that's part of build stage that will do something. In this case, we'll echo hello and the user. We can define another job, a test job that's part of test stage. So this stage kind of defines the order that things will execute. We have another job there, test job 2 as part of a stage test that do an echo and a sleep, and another job that's deploy, deploy-prod, part of stage deploy that will do another echo and has some other properties. And once you push your code with this YAML file defined, you can see inside the GitLab user interface this pipeline being created, where you can see the jobs being executed. Each column is a stage, so you can see which jobs passed, which ones are executing. So the blue ones are executing, and the gray one didn't execute yet because it's waiting for the others. So basically in GitLab-CI, we have what we call runners. So when you push our code, GitLab triggers a pipeline there, and runners are listen for those and grab the jobs and execute it. Those runners can be shared runners, which are basically machines or Docker instances that are made available by the infrastructure to everybody in the GitLab instance to use. We have also group-specific runners. So for instance, if you have a team in Salsa and you want a faster machine, you can make available a specific machine just for your team. And you can also use your own machine as a runner. So there's a really easy way that you can set up your own machine. You install a few things, and then it's done. Your machine will start to listen for new jobs to run, and grab those, execute, so you can configure that to execute things for your project, for instance. And what is really interesting about GitLab-CI is that you can define a pipeline inside your repository, but you can also, inside that magic name, .gitlab-ci, but you can also, which is the default, but you can also change it under the configuration to point to somewhere else. So you can point to another file in the same repo. Let's say that you rename it your .gitlab-ci.yaml file to foo.txt for some reason, and you can point to it. You can also point to a path in another GitLab repo. So for instance, this is an example from the subsystem team. You can point to a file called recipes/debian.yaml at subsystem team-pipeline. And you can also point to a URL. This is very interesting because you can execute a pipeline that you didn't do. You can reuse other people's work. So just a quick thing about Salsa and Salsa CI. So Salsa provides shared runners that are available for all projects to use. And a really nice thing is that the Salsa CI team developed a pipeline for Debian packages that I believe most of you use it. So you just go to the configuration and you point that file to that one that we saw in the previous slide. And from the Salsa CI team pipeline documentation, once you push new things to your repository, it can build your package from source code. It can execute Lintian, a reproducible build using reprotest, pew parts, auto-pkg test, build log scanner, and there are other configurations and advanced use that you can do if you look at the documentation. Right, so back to the kernel. Why am I talking about GitLab-CI for Linux kernel development? So here it's not about packaging, it's about development. We will talk a bit about packaging in a few moments. If you were in my, so we'll go through each of those buckets together in a moment. So, and if you were in my workshop, you saw that in kernel, all the patches are sent by email. And this is usually like the current workflow in the kernel. So first, you are a developer, you are working on your patch, so your patch is work in progress. We are in the first box there. Then you think that your patch, your work is good enough, so you submit your patch to a mailing list. Then people review it, and if people think it's good enough, they will accept and merge your patch. So we are in the third box there. And merging a tree of some maintainer, right? From there, we can go to paths. So let's start with the top one there. There is some transparent CI system that you don't know, you are not really aware, that will pick up this branch, run some tests, and maybe find a regression that you introduced. Then it will notified, so we go to the last box here, so the maintainers or developers get notified about this regression, and eventually you will start working on the fix again, and then we restart this process, right? So another patch needs to be done. The other possibility from the third box there is that this patch is deployed to a product. We can go up again if there is a CI monitoring this product, or the end user can find a regression, and eventually these will be notified to maintainers and developers about this regression, and we restart this process. So, regarding this workflow, there are a few limitations of the magic box on top, because it kind of requires a complex reporting system to not report false positives. Because if this reporting system starts reporting things that are not relevant, things that are not the fault of the code, is the fault of the CI system that is malfunctioning, is the fault of the test suite that it wasn't updated, or just reporting something that is low priority and won't fix. So people start ignoring the results, or they even start complaining about getting spammed. So as a consequence, we get a low community engagement about testing. And if nothing was reported at all, people were not sure if the tests were actually run or not. Maybe it was and everything was fine, or maybe the CI system just didn't work. We don't know. So in this model, usually every developer does their testing prior to submission, their own way, the way that works for them, and then they submit the patch, and then someone will report, oh, it doesn't work for my case. So the testing is not a standard thing. So what I'm saying is that a workflow with GitLab-CI can fill these gaps. So let's understand a bit how. So this is the same workflow that we just saw with two small differences. So the first difference is now we have a green box there. So when a patch is work in progress, the developer or the maintainer can test the patch set on GitLab-CI, on their own instance of GitLab-CI, to check if everything is fine, and if not, then rework on the patch. Then after submitting to the mailing list, the maintainer can recheck to see if what the maintainer was expecting to be tested was actually tested. And the next difference here is the third box. So we have like the patches only gets accepted and merged only if all tests are green. And so we can see that we are kind of bringing the test process in the beginning and make it more transparent to everybody involved here. And there are a few advantages of doing this. Here, in this case, that patches are merged only if all tests pass. It's nice because we can, so detectable regression aren't merged in the first place, so we don't need another patch to fix the regression. So even small or low priority ones, so we wouldn't bother maintainers to fix these small things. If the issue is in the test suite, developers are motivated to get involved and fix them or annoy the person responsible for that because it's a requirement for the test to pass, so the patch can be merged. If the issue is in the infrastructures, developers are motivated to report back. So we can see that this model motivates developers and maintainers to be mindful of tests, and this increases community engagement and testing culture. Also here, failures are detected before merge or even before submitting the patch. So when we are promoting an always green culture, which means that all tests must be passing before merging, this simplifies a bit the CI system as well. So no bisection is required, no complex reporting system is required, no this problem of taking care of false positive is not that big anymore. And this is also good for newcomers because sometimes you don't know all the bits that you need to test. So if you are just starting and you did some code and you are testing for your case, maybe you are not aware of all the test suites, so you can just execute the whole test just pushing a button. So now we already passed those 3 items there. I would like now to show you 3 pipelines that we can use to test the kernel, similar to what you do with subsystem. You just point to a pipeline that's already there. So we'll cover DebConf, Media-CI, and KCI GitLab. So first, DebConf. Let's go through it. What it is DRM-CI. So it's basically a Git-CI pipeline for the DRM kernel subsystem, which is the graphics stack. And this is a pipeline that's defined in tree. It's already inside the Linux kernel code. And what it does, basically the supported test, so it's small to understand, but I will guide you through these boxes. So this is the current pipeline that we have. In the first stage there, it's a written container. So there we build all the containers or rootfs images that we'll need with all the dependencies that are required so we can run the tests. The second stage there is the build stage. There we, for instance, the second box, we build the kernel. For instance, the second box there, we are building a build, so it's called build, column ARM32, so we are building the kernel for ARM32. And we are also building the test suite used for graphics, which is called IGT. So it's IGT graphics testing tool. And we are building for different architectures. And the last ones there, we are building the kernel with different configurations, just for sanity check. And then we run the test for those supported drivers. So each of those stages now are for a specific driver, and we test those on specific boards. So for instance, the third one is AMD GPU. So we test, we execute the test on, there's only one job there, which is device called Stone, which has the AMD GPU graphics board. So we can test the AMD GPU driver. So we run IGT test suite inside this board. The other one is the Intel i915 driver. And we have more boards with this graphic board. So we have there 1, 2, 3, 4, 5, 6, 7 different boards that we can check if tests are still passing. And we have the same thing for the other drivers. So MediaTek, Meson, MSM, Rockchip, Panfrost. Just this last one is a bit different. So this last stage is called software driver. So those are run inside a virtual machine. So we have Virtual I/O GPU for virtualization, and we also have VKMS, which is basically a driver that emulates one of the graphics card, just the KMS part. So we can, it's a driver just made for testing. So we can execute the test suite on top of it and exercise the core of the DRM to check for some specific bug. So how it really works. Right now, DRM-CI only works on the free desktop GitLab instance. So what it is, so we as Debian, there is the Salsa GitLab instance. The graphics people have their own GitLab instance called free desktop. And every time tests are dispatched there is a special infrastructure that connects to labs in different locations of the world, and those labs have like racks of different devices, and those labs will dispatch the jobs to those different devices. So device-specific tests are dispatched to the labs, and labs dispatch the job to the specific devices. Then results are collected, and we can check on the GitLab UI. So how can you use it? If you do something inside DRM-CI, inside DRM, you can just create an account on gitlab.freedesktop.org. Then you can create a Linux repository there and just point the CI/CD configuration to this file. So driver/GPU/DRM/CI/GitLab-CI.yaml. And you just need to ask to join this group, so DRM-CI/CI-OK group. So you can have the privileges to use the CI, the infrastructure, which is basically just sending an email to the community. And then it's done when you, every time you push your code to your repository, this pipeline will be run. So a few limitations. This is specific to the DRM subsystem, unfortunately, and it only works on the free desktop GitLab instance. And also it shares resources with other projects in free desktop. So sometimes you will wait for it to be executed. It takes a bit of time. So now let's talk about Media-CI. So what it is. So Media-CI is basically has the same idea of DRM-CI, but instead of being to the graphics subsystem, it is for the media subsystem. So video for Linux, things related to cameras, related to codecs, decoders. Instead of having it defined inside the Linux kernel tree, it lives out of tree. So that is the link. And the problem here is that DRM-CI folks and Media-CI folks, they kind of work independently. They don't share much knowledge. So they are doing their own code. There's no overlap. So how to use it? You can set the configuration to point to this URL, and it should work. So you push your code, and you should have your kernel being tested on Media-CI. So what Media-CI supports? Media-CI is a bit different from DRM-CI in the sense that DRM-CI, the focus of DRM-CI is to test on real hardware. But Media-CI is doing a bit different. They are focusing on linting, on static checks. So the static jobs there, they check several things. So if you were in my workshop, you probably executed the check patch. So it uses a check patch and several other kind of tools that will see if you are using deprecated functions, for instance, and other things. It builds for different architectures, with different compilers. Then it builds the documentation. It checks for bisectability. It is just checking for bisectability about compiling. This virtme one is just, virtme is a wrapper for QEMU. So here it is executing testing inside a virtual machine. So the interesting thing about the media subsystem is that it has several fake devices, so virtual devices that you can exercise the API without having a real hardware. So that's what they do. Here, execute the testing tools on top. And they also check if the patch was sent by someone they trust. There's a trustable list of people, and it generates a report summarizing everything. So limitation, it is specific to the media subsystem, and is yet another group working separately. All those builds, static checks, booting could be used by all subsystems. This is common. And could benefit the entire community. Instead of having separate implementations that works for only their cases, we decided to propose a new one called KCI GitLab, which is supposed to be more generic. So let's understand what it does. So on February 28th, I sent this patch called KCI-GitLab, introducing GitLab-CI pipeline for kernel testing. This work was developed together with the kernel CI community, and it allows tests to be executed on any GitLab instance. It's a more generic solution. It's very customizable and extendable with a feature called test scenarios, which is useful for subsystems to specify their own specific tests. And the current state is version 2. We got several feedback from lots of people, and version 2 is required. So how does it look like at the moment? So it's very simple, because the idea is to have a base where people can build other things on top. So the idea is that DRM-CI and Media-CI and other CIs would migrate to this solution. So we have a container stage, which is the same idea as the others. We have also static checks. So for now, we are doing just 2, so check patch and match. We also build the documentation. We build the kernel. And if you open the kernel job there, you can see that we build the kernel with to different architectures, to different configurations. And people, driver maintainers, can easily override those in their own specific files and selecting very easily which configuration they want to use when they are pushing, and also advertise this to other people working on the same driver or the same subsystem. And we have a cache staging for optimizations. So proposed future features, we would like to expand the static checks here. So kernel provides a lot of static checks. So there are DTBS checks, parses, YAML, link DT, doc validate, code check, and several others. We can also leverage external testing labs. So similar to what DRM already do, we can connect to Lava Labs, or we can connect to other bare metal labs. Anyone who wants to submit a patch and other labs are welcome. And also, we could use the Kernel-CI provided labs. So Kernel-CI is another project, and they intend to be like a hub. One of the parts of the project intend to be a hub of labs. So instead of the CI instead of the CI being aware of how to connect to a different lab, it just connects to Kernel-CI, and Kernel-CI connects to all those different labs. We could also add user space tests on top of virtual machines, similar to what DRM and Media-CI already do. But instead of executing their own specific tests, you can already execute the tests that are inside the kernel itself. So the kernel provides what we call k-self-tests, k-unit tests, and also we can run those subsystem-specific tests. And other integrations, so there is this interesting project called KCIDB, which is meant to be like a central database for all the kernel CI systems around. So everybody with a CI system is welcome to test and submit results to this database. Then we can mine those data and get specific insights. Right, so how to use it? It should work out of the box. You just grab the patch that is published, apply to your patch, enable CI CD in your repository, and push your code, and it should work. So there is documentation available if you are interested in more details. Right, so just a little bit about CI for Linux kernel Debian packaging. So I sent an email to Ben regarding how CI was being done in the kernel, and he sent me some pointers, which was really nice. So he, in 2022, he made this post about the work that he did to add support to basically Salsa CI, but for the kernel package. And he explains the challenges that he had in the middle. And he told me that the current missing bit there is runtime tests. So on top of virtual machines that could verify that everything is fine. So if you are interested, I recommend to read it and contribute. So how I would like us to move forward. So I really would like to see more joint efforts and contributions, and because it's all so independent, all the testing systems are so independent, they're doing their own thing, and I really think that one could benefit from the work of the other. I would like to see more people engaged in the testing culture. I would like to make proper testing easier to everybody, so everybody could just push a button and see the test results, and also increase the quality confidence for newcomers. I was telling someone that the idea is, instead of you send a patch and someone and waiting for some rude person to be rude at you, you can just check before, and more easy. So that was basically it that I had prepared for today. A bit faster than I was expecting, but then you have more time to walk around them. Yep, so thank you very much.
have 15 minutes more for questions. If someone has a
Questions?
question.
No questions? There.
Hi, great job. Thank you very much for your presentation. I missed it. I didn't see the documentation for your for the CI you're proposing. It's already in tree in the kernel or not?
For which CI?
The kernel CI, the last one.
Yeah. It's in the patch. I can send you. If you look at the name of the patch, it's fine to.
Okay.
It's easy to find it.
So, okay, and other stuff, I'm very curious about the runners that you use in the free desktop, for example, environment. What are the requirements that you will need to have the similar stuff in Salsa CI, in the Salsa?
Yeah. So the specific requirement is basically because, so the runners are, there is a sponsor who provides some machines, and the keys to access the labs are inside the runners. So we would basically need to request the keys for the labs and set up those runners, and how they it managed to submit the jobs to specific ones is using tags on GitLab-CI. So you can say, send this job to these runners who, because they have the key to access those labs, so they can dispatch jobs to that specific labs.
Yeah, sure. Well, I will reframe my question. The requirements for the runners are documented somewhere?
Yes, there is, well, the requirement is basically, that's basically the key to access, but like the requirements for like higher, there is a page that says the capacity of the runners it's available in the free desktop infrastructure.
Yeah. The problem, for example, that we have in Salsa is the Salsa share runners don't support very well QEMU. So running a virtual machine is very, very slow. So
yes.
We face this kind of limitations, and for improving the CI of the Debian kernel packaging, we will need other type of runners. And, yeah.
Okay, yeah, I can send you the page. There's a description of which machines are being used. They are like powerful machines.
Great.
Yeah. And the idea, and one question that I'd like to ask you actually is, because the idea for me to present this is basically to share how the kernel is doing things. So my idea is, how could we use this, maybe the same idea, so we can join efforts with the kernel team, maybe, so we could use some of those tests that might be useful for both cases. So yeah.
That will be awesome. I'm not part of the kernel team, but I will very happy to join work.
Awesome.
Cool.
No more questions? Then, if we don't have more questions, please welcome Helen. Thank you, Helen.
Thank you.